Hi guys, in this video we're going to have a look at similar shapes. So this is part 2, and this time we're going to concentrate and look at the area and the volume. So just a quick reminder, with similar shapes, all the angles are always the same, and we're always looking for the scale factor. Now, the most common error that people use, or do, sorry, with similar shapes when dealing with area and volume is they use the wrong scale factor. If you're dealing with area, they'll probably use the length. If they're dealing with volume, again, usually they use the length, or vice versa. So it's absolutely crucial that you get the right scale factor. So I put a little hint here. The best thing to do is to find the length, area, and the volume scale factors before you do anything, and then you should be okay. So I'll just go through an example of what I mean as to why they're different and how we can work them out. So here I have two squares, excuse me, and they're similar. Okay, this one has a length of 1 centimetre, and this one here has a length of 10 centimetres. So just like in part 1, when I dealt with the length scale factor, I go from small to big. How big is it? Well, from 1 to 10, it's got a scale factor of 10. It's 10 times bigger. Okay, nice and easy, as I say, from part 1. Now, if I work out the area of these two, well, 1 centimetre times 1 centimetre gives me 1 centimetre squared. And sorry, this is 10, isn't it? So this would be 10 centimetres times 10 centimetres, which gives me 100 centimetres squared. So when I compare the areas, it goes 1 to 100. So it's 100 times bigger. So as you can see, the length scale factor and the area scale factor are different. They are not the same. Okay, if you were to use the length scale factor and say, okay, the area of this one is 1 centimetre squared, using the length scale factor, you times it by 10, you'll have 10 centimetres squared. But as I've just proven here, it's not. It's 100 centimetres squared. So you need to use the right scale factor. Same thing with volume here. If I was to work out the volume of these shapes, I've just made them into 3D, exactly the same length. So this one here is a 1 by 1, 1 by 1 by 1, 10 by 10, 10 by 10 by 10. Okay, so the volume of this one would be 1 centimetres cubed, and 10 times 10 times 10 is 1,000 centimetres cubed. So again, as you can see, the volume scale factor to go from this one to this one is 1,000. To go from 1 to 1,000, the scale factor is 1,000. So again, the volume scale factor is different to the area scale factor, is different to the length scale factor. And that's what you need to bear in mind, and they're the ones that you need to find out when doing any question. You need to make sure you're using the right one. Before I go on to doing a few questions, if you know the length scale factor, in this case I know it's 10, and you want the area scale factor, you might have already spotted that what you can do is just go 10 squared will equal 100. Okay? So that is how you can get the area scale factor. Easy to remember because the area, the units are always squared. Exactly the same thing down here with volume. The volume unit's always cubed. So if you know the length scale factor, you can cube it to get the volume scale factor. Okay? Which is what we're going to be doing in a few of these examples. Also, what you can do is if you're given the area scale factor, which is 100, and you need the length scale factor, instead of squaring, you can do the opposite and square root it, and again, that will tell you what the length scale factor. But hopefully that will become a bit clearer in the couple of examples that I've got coming up. So let's have a go at this one. This one here, it says, shape A has a volume of 60 centimetres cubed. Work out the volume of B. So I need to work out the volume scale factor. But I've only been given one volume, so I can't use that to help me. What also I've been given is I've been given two lengths. So this side here is 2, this side here is 4. So what I can work out is the length scale factor by comparing these two lengths. 2 to 4, so small to big. How do I go from 2 to 4? Well, it's twice as big, so I'm timesing by 2. So the scale factor, the length scale factor is 2. Now, I don't want the length scale factor because I'm dealing with volume. So what I need is the volume. I'll just put SF, scale factor. And just like I said over here, to find that, if you know the length scale factor, which is 2, if you then cube it, it will tell you what the volume scale factor is. So 2 cubed, so 2 times 2 times 2 is 8. So the volume scale factor is 8. And that's the one I use when answering this question. So if A, which is the small shape, has a volume of 60 centimetres cubed, and I want the volume of B, which is the big one, I need to times it by the volume scale factor. Okay, so if you've got a calculator, cool, you can do it. I mean, it's not too hard. But obviously 8 times 60 will give you the volume of B, which we said was 480. And again, make sure you get your units right, centimetres cubed, because it's volume. Okay. Part B, it says B has a surface area. So this shape here has a surface area of 100 centimetres squared. Work out the surface area of A. So this one is dealing with area, so I can't use that scale factor, and I can't use that scale factor. I need to work out the area scale factor. And just like I said here, if you know the length scale factor, which is 2, to get the area scale factor, just square it. So 2 squared, so 2 times 2 is 4. So the area scale factor for this particular example is 4. So if B, the big shape, has a surface area of 100 centimetres squared, and I want to go to the small one, just like before, if you're going from big to small, you divide by the scale factor. So I'm going to do 100 centimetres squared divided by the area scale factor, not the volume or the length, the area scale factor, because that's what I'm working with. So I'm going to divide by 4, and of course then I'm going to have 25 centimetres squared for the area of A. Okay, so I hope that makes sense, but if not, I'm going to go for a couple more examples which hopefully will clarify those steps there. So bear with me a second. Okay, so here is another 2 examples. This one here is dealing with cylinders. So in this question, let's have a look at what we've been given. It says the volume of A is 17 metres cubed. The volume of B is 459 metres cubed. So I can compare the volumes, so I can find the volume scale factor. So that's what I'm going to do straight away. The volume, again, SF for scale factor. So just like when I was doing the lengths, if I don't know what it is, looking at that, 17 to 459, I'm not sure what that is, just do big divided by small. And that will tell you what the volume scale factor is. So 459 divided by 17, we get 27. Okay, so the volume scale factor is 27. Now, the actual question, if the height of A is 5, put that on if you wish, 5 metres, what is the height of B? So this is talking about the lengths. Okay, the length of that is 5. What's the length of that? I cannot use the volume scale factor because I'm dealing with lengths. So I need to find what the length scale factor is. You might remember me saying if you got the volume scale factor, to go back to the length, you do the opposite of cubing, which is to cube root. So I cube root 27, and that gives me the length scale factor of 3. So once I know what the length scale factor is, I'm going from small to big, so I'm going to times. So 5 times by the length scale factor, so 5 times 3 gives me 15 metres. Part B, the surface area. So this time I'm dealing with area, so I need the area scale factor. Now, once you know what the length scale factor is, just like in the previous example, you can square it to find the area scale factor. So 3 squared is 9. So the surface area of B, so the big surface area is 72. What is the surface area of A, which is the smaller one? So I'm going big to small, so I'm going to divide. So I've got 72 metres squared divided by my area scale factor of 9. So 72 divided by 9 gives me 8 metres squared. So remember your units, area squared there. And last but not least, they don't always have to be nice shapes. They could be a little drawing. So here's my attempt at drawing two similar snowmen. And again, let's go for it. So in this one here, the area of A is 22 meters squared. The area of B is 49.5 meters squared. So again, they're giving you two bits of information here, both of the area, so I can use this to find the area scale factor. And again, it's not quite obvious how to go from one to the other, so do the little trick of big divided by small to find out how many times bigger it is. So let's bring the old calculator over again. So 49.5 divided by 22 gives me 9/4. You could use the fraction, or if you press the SD button, you're going to have 2.25. Either the fraction or the decimal will be absolutely fine. So part A, the actual question, says if the volume of A is 37 meters cubed, what is the volume of B? So I need the volume scale factor. Okay, but there's no way of going from the area straight to the volume. You've got to go backwards to the length scale factor first. So the length scale factor, so to go from the area back to the length, if I go from length to area, I square it. So do the opposite to go back. So I square root 2.25. So let's do that. The square root of 2.25 is 3/2. So again, you could use that as a fraction, or it's 1.5. But like I said, if we're dealing with volume, I need the volume scale factor. So now I've got the length scale factor. I can cube that. So 1.5 cubed. 1.5 to the power of 3, so cubed, gives me 3.375. Okay, so now I've got the volume scale factor. I can use that on here. So the volume of A, that's the small one. B is the big one, so small to big, so I'm going to times. So I've got a bit of space, let's do it here. So 3.375 times by 37, because again, it's going from small to big, that's why I times. So times that by 37, and we get the answer of 124.875, and the units would be meters, and because we're dealing with volume, meters cubed. And last one here, it says B has a height of 7.5, so again, you can draw it if you wish. 7.5 meters. What is the height of A? So I'm going big to small. I'm comparing the heights, so I'm comparing lengths, so I'm going to be using the length scale factor of 1.5, and because I'm going from big to small, I'm going to divide, so 7.5 divided by the length scale factor 1.5, so 7.5 divided by 1.5 gives me 5 meters for the height of A. So hopefully that makes sense. And remember, when dealing with similar shapes, you've got to make sure you're doing the right, or using the right scale factor, whether it's length, area, or volume. And also remember, guys, for the exam, similar shapes have the same angles. Okay, you don't apply these scale factors to the angles; they have the same angle. So hopefully that helps. Thanks for watching.